Today I'm going to show you how you can make a seamless glove mold using fast setting materials. Now in today's video I'm going to show you how you can use fast setting materials for a fast turnaround on your molds and casting projects. Now in this video we set a couple of goals for ourselves. Number one goal is we want to capture the detail in the original sculpt that is in clay. And we want to make sure that we don't disturb the detail that's in the clay. So our regular stippling technique on this model won't work. So I'll show you what I use for that. And then furthermore, we want to create a seamless glove mold so that the castings coming out of this mold are going to have a minimal post-finishing effort to get them to a finished state. And we want to also make sure the entire project in one day. So we wanted to use fast setting material so we can make the mold and castings within a very short period of time. So we set ourselves a little bit of a challenge there. Now let's just jump into this project and see how it's done. So here you can see our original model that we have to work with. This is sculpted in oil-based clay. And as you can tell, there's a lot of detail on the surface here, and we don't want to disturb that detail by stippling the material into the fine grooves. And for that, I'm going to show you a different technique that we use in the foundry where I worked for years. Now, like I mentioned, we're going to be using the Dragon Skin 10 very fast for this project because we do need the speed of the material. But important thing to keep in mind, this is a 1-to-1 mix ratio with a 4-minute working time. So the working time is extremely short while the cure time is 30 minutes. A fast turnaround on this project is really important. So we're going to go ahead and dispense the Dragon Skin. Again, this is a 1-to-1 mix ratio, so I can simply mark my dispensing cups and then go ahead and dispense the material. Now you notice I'm not using a lot of material here. Make sure that you mix thoroughly when working in small quantities. And now the reason why I'm not using a lot of material is that we have a small area to cover. So again, scrape the sides and scrape the bottom of your mixing container. It's really important. And work quickly because the pot life of the material is 4 minutes at 73 Fahrenheit room temperature. Now the material is brushed onto the model. Notice I'm not stippling the material onto the model. I'm simply brushing it with long strokes, applying the rubber to the actual surface. Now the reason why I'm not stippling the rubber onto the model here and rather brushing it on is because our model is made out of clay and I'm worried that I could add texture to our sculpt. So instead we're going to brush the material onto the model and then use some compressed air to push the material into the detail of our sculpt. Now remember, the first layer on our brush-on mold is the most important layer of the entire mold. This is where you capture the detail of the sculpt. So you don't want to apply too much material where it's going to just sag and droop off, but just enough material that it covers the entire object. If you do see any kind of drips like this here, make sure to remove them. We don't want to have them present on the first layer. The first layer is now allowed a partial cure for 15 minutes. Because the Dragon Skin is a translucent material, we're going to add some Silk Pig White to the second layer. This is going to help us differentiate where a layer of material was already applied. The Silk Pig White is mixed in thoroughly with the Part A of the Dragon Skin 10 very fast, and then the two components are combined in a clean mixing container. As always, make sure to scrape the sides and scrape the bottom of your mixing container thoroughly, and keep in mind the 4-minute working time that we have with this material. And I'm simply going to go ahead and brush the material on. And because this is the second layer, there is not detail that we need to capture. We don't need to actually use any forced air for this layer. So simply brush on the second layer, Again, the color difference between the original unpigmented and the white is clear here, and we can easily see where the material is applied. If you do ever have the material set up in the mixing container and you cannot finish your application, it's not a big problem. You can always mix a second batch and continue the application process. I do like to emphasize that I personally like to apply the first layer all in one shot because it is our detail layer. The second layer you can apply in multiple stages. Now, once you apply the material, it's going to be allowed a partial cure for 15 minutes. Now, if you're not aware what a partial cure is, you can always do a finger test where you touch the silicone somewhere where it's not important, not on your model, of course. And if the material comes off on your glove, then you're not ready for the next layer. If the material is tacky but does not come off on the glove, then you're ready for the next layer. Now I'm going to dispense and mix the same amount of dragon skin very fast. However, I'm adding some Silk Pig Green to allow me to see where I'm applying the liquid silicone rubber. The Silk Pig Green contrasts the previous layer, which we added the Silk Pig White, nicely, and we can clearly tell where I'm applying the liquid rubber. The material is now again allowed a partial cure for 15 minutes. The process is repeated to apply layers 4 and 5. Now I'm changing the color of the rubber between layers so that I can see where I'm applying the material. The thickness of the mold I'm aiming for is about 1/4 inch. And that's because the mold itself has to be able to invert on itself, but yet be very stretchy and durable. Keep in mind that the thicker we make the mold, the less flexibility it's going to have. Once the final layer has been applied, all the layers are allowed a full cure of 30 minutes. And just to show you where we're going with this project for the support shell, you can see the parts. Here's our soft silicone rubber mold. And we're going to first create that one side of the support shell. This is the collapsible soft plug that we're going to be making towards the end of the support shell process. The reason why I decided to make a soft plug for the center of the hand here is because I was not able to create a hard, rigid part of the support shell that would fit in here. It was too difficult of a space, so a soft, collapsible plug like this just made sense. So you can see what the final result is going to look like when we're finished. After our molding rubber has fully cured, we can start prepping to make the support shell. And here I'm going to be using some Sculptix oil-based clay. This is sulfur-free clay to build up the two halves of our support shell basically. And here in the middle where the fingers are, that's going to be our soft collapsible plug. Now it's just a space holder. And a couple of keys around the model to help the two halves of the support shell align. And now we can apply the universal release agent to the clay. The application of the liquid release agent versus an aerosol allows me to apply one single layer of the release versus using a spray brush spray technique with the aerosol. This way I am able to more effectively apply the release agent where I want it to be. Also, make sure that you don't allow the release agent to pool. You don't want to bathe the object in the release agent. You want to apply a thin layer and allow it 5 minutes to dry before applying any support shell material. Now, like I mentioned, we're going to be using the Smoothcast 300 for our support shell for a very simple reason. This is a fast setting material. It has a mix ratio of 1:1 by volume, so it's very easy to use. But more importantly, pot life is 3 minutes and a cure time is 10 minutes. So we don't have to wait a long time before making both parts of the support shell. Another important aspect of this material being used for a support shell is the viscosity. So we need to, it's 80 CPS, and we need to thicken up this product where it's basically a paste. So we're going to be using the Urafil 11 for that. Now, the Urafil 11 is a fiber-based filler for thickening of materials such as silicones, urethane plastics, and epoxies. So it can be used for a variety of different applications. Now, the ratio of filler to resin can vary based on what you're trying to achieve with the filler, with the thickener. So if you discover that you need a little bit more powder, you can add some more to your mixture. Just keep in mind the mixing and working times if you already combine the two, A and B, and the powder together. Here I'm trying to achieve a nice thick paste. And for that purpose, I'm going to be using 1 part of A, 1 part of B for the resin, and then 2 parts of the Urafil 11 to get it to a nice thick consistency. As always, before dispensing any materials, make sure you pre-mix them thoroughly. The part B of the Smoothcast 300 is dispensed, 1 part of the resin, and then mixed with 2 parts of the Urafil 11 that we dispensed earlier. The 2 components are now mixed well together by scraping the sides and scraping the bottom of your mixing container. And then we're going to dispense the part A, just like we did the part B, and add it to the already combined part B with the Urafil. The 3 components are now mixed thoroughly until they get you a nice paste that you can easily trowel onto your support shell setup. It is really important that you mix thoroughly by scraping the sides and scraping the bottom of your mixing container. Unmixed material won't end up as lumps in the support shell itself. Now, I'm quickly going to double mix the material. You don't want to end up with unmixed material in your support shell that would weaken the structure of the shell itself. And once we mixed it, we can then apply it directly to the support shell. And you can see here how thick that paste, the Smoothcast 300 paste, should be about. Because the Smoothcast 300 is an exothermic casting resin, it will generate heat. If you start feeling the material inside the mixing container heating up on your palm that you're holding the container with, that's a sign that the exothermic reaction is taking place and the material is starting to set up. So you want to make sure to get the material out of the mixing container so that you actually get more working time. So get the material out of your mixing container and start spreading it onto your working surface. Keep the short working time in mind. So once you get the material out, you can start spreading it out. You can see here I'm using first a brush, and then I end up using the mixing stick to move the material around. Now allow this first half of the support shell to cure fully for 10 minutes. Now that the first half of our support shell is done, we can go ahead and remove that Sculptex oil-based clay. While most of the clay is removed from this side, do note that the clay that's in the palm area, that's going to become our soft plug, is staying in place. This is a placeholder while we create the second half of our support shell. As a matter of fact, I'm going to add a key into that so that the plug itself will register well into the support shell. Now, once that is all set, we can go ahead and apply some universal release agent to all the areas where the new Smoothcast 300 support shell is going to be applied over. So universal release agent releases urethane products from each other. Once the release agent is applied, we're going to let this dry for about 20 minutes before moving on. I can now go ahead and mix the second batch of our Smoothcast 300 and Urafil 11 mix for the second half of our support shell. And then once you have that mixed, we can go ahead and apply it to the second half of the support shell. Keep in mind to work fast. This material does set up very fast, and you don't want to be caught off guard with not having the material out of the container or not have it spread on the surface itself. So get it out of the mixing container, spread out the mass of the material, and then you can go back in with a brush like I did here to kind of even it out as far as the thickness of the overall structure. Because keep in mind the thickness of the support shell should be even all throughout. Now that's not possible 100%, but we're aiming for that. So once this is applied and smoothened out, the Smoothcast 300 is now allowed to cure for 10 minutes before moving on to the next step. Now, before demolding, I'm going to go around the perimeter of the mold, and I'm just going to trim some of that Smoothcast away, clean those areas where the mold comes together. And I can go ahead and pop these two halves apart now. Will help from the screwdriver. And now we're going to expose that clay area that we're going to make a plug off. For that, I'm going to go ahead and carefully remove our original sculpt that's in the silicone rubber. And here you can see I'm removing that clay from the plug that we're making. The area where the clay was in the support shell is now cleaned out using some isopropyl alcohol. Make sure you scrape most of the chunks out first with a tool, and then come back with a hard bristle brush to wipe away some of the gunk. Now this is allowed to dry before moving on to the next step. The next step is to drill some holes around the perimeter of our support shell. This is where the support shell will be bolted together to hold the mold in place. Now I'm using 3/8 of an inch drill bit here. And once those holes are drilled, we can come back and put some release agent inside our mold. Now I know that I'm making a soft, flexible foam plug for the center where the fingers come together in order to demold it and pop that out. I'm using the Ease Release 2831. This is the release agent for urethane foams. And now we can go ahead and put that support shell back together. And you can see that the cavity where the Sculptex clay was is now hollow, and that's where we're going to be pouring the plug material into. So once the mold is bolted together, we can go ahead and start dispensing and mixing our plug material. Here you can see that core one more time that we're going to be working on. I'm going to screw that sculpt back on its working base. And now we're going to go ahead and start to work with the Flex Foam at 10. Now the Flex Foam at 10 is a by volume mixing material, so we don't need a gram scale. It's a 1-to-1 mix ratio by volume. It expands about 6 times its original volume that you mix, has a working time of 50 seconds, and a full cure of 2 hours. To get a good rise out of flexible foams and foams in general, it is really important to thoroughly pre-mix and shake the individual components before dispensing them. And then we can go ahead and dispense it equal amounts, part A and part B, and then mix them together in a clean mixing container. Keep in mind that with the foams, you want to whip in as much air as possible into the mixing by keeping in mind to scrape the sides and scrape the bottom off the mixing container. Now the product is poured into our cavity and has allowed a free rise to fill that cavity. Now the easiest way to estimate how much material you're going to need to fill a void like this is going to be by understanding the expansion ratio of the material that you're using. Knowing that the expansion ratio for this product is about 6 times its original volume, I know that I need 1/6 of the entire space to fill that void with material. And then if you come under the desired level, you can always mix up a little more and top it off. And here you can see why it's important to put the release agent all around the area where we pouring the foam. If the material rises out of that cavity and spills over onto the support shell, it will be a really easy cleanup versus having no release agent present. You can also measure the void that you're trying to fill and use our materials calculator to help you determine how much material you're going to need for that filling. Once that fill is expanded, we can allow it a full cure for 2 hours before demolding. After the 2-hour full cure for the foam, we can finally demold our model. Simply going to pop the 2 halves of the support shell open, and then we're going to pry out the model and trim away some of that foam collapsible plug that we made. Now, this is why it's important to choose a foam that is firm enough to keep the shape of the original when casting into the mold, but flexible enough so it can collapse and squeeze down to be able to remove from the mold setup. To help facilitate the silicone being stretched over silicone, which creates surface tension, we're going to use a little bit of talc or baby powder here on the rubber itself, and then I'm simply going to slowly pull the silicone over the existing model. Here you can clearly see why we chose to go with a very stretchy material like the Dragon Skin 10. It's very stretchy, you can pull it hard and get it over those difficult areas of your casting, and it won't tear easily. So the elongation and break, which is 1000% on the Dragon Skin 10, comes in very handy and is the main reason why I chose to use this product. The silicone drips at the bottom of our mold, which now becomes the opening of the mold, are simply cut away for several reasons. Number one, it's where the mold is the weakest, and if you put a lot of stress on that, it could tear in that area. So by cutting those away, we're giving the mold a nice, even thickness all throughout that opening. Furthermore, it's going to be easier to work with the mold and cast into it by trimming that away. A little bit of release agent around the top and the sides. This is, again, universal. We're casting urethane resin into this mold, so if anything leaks between the rubber and the support shell, it won't actually stick to the support shell. So it's really important to have some of that on the support shell. And here you can see the plug is going between those fingers. It's going to help keep them in place nicely. And we can now set that into the first half of the support shell. And because we have all kinds of keys going around the support shell and the plug, those line up very nicely and fit very tightly together. The mold is now bolted together, and we can go ahead and focus on mixing up some resin. To cast our model here, we're going to be using the Smoothcast 57D. This is a semi-rigid casting resin that's transparent or translucent by color. It does have a very convenient mix ratio of 1:1 by volume. And the key here is that the short working time, 3 minutes, it allows us to do rotational casting while a full cure is achieved in 30 minutes. I can simply mark my dispensing containers and then proceed to dispense the part A and part B and mix them thoroughly together by scraping the sides and scraping the bottom off the mixing container. I'm simply going to pour this into the mold, and you can see I'm actually kind of hitting the edges. And then we're going to slowly rotate that mold, getting a nice detailed layer. The Smoothcast 57D has a gradual cure, which is specifically meant for rotocasting hollow pieces versus a snap cure of a regular resin. And the material itself is translucent, which makes it ideal for painting over. You don't have a base color that you're trying to cover up. Now, when you do the rotational castings like this, make sure you spin the mold in a 360-degree way so that the resin covers the entire inside, even if some of it ends up dripping out. The material is now allowed a partial cure for 15 minutes. Additional layers of the Smoothcast 57D are dispensed, mixed, and rotocasted into the mold the same way that the first layer was, until we build up a thickness of about 1/4 inch on our casting. One thing to keep in mind when casting these materials in thin cross sections like this casting here, this is a hollow casting, and the side walls of our castings are only about 5 millimeters thick, is that the exotherm is quite slow to take place, and the material usually requires a longer cure time before it should be demolded. Otherwise, you're risking deforming the casting. So keep that in mind when you're working with these products and you're applying them in thin cross sections. The material is allowed a full cure for 30 minutes. However, like I previously mentioned, you may need to let it cure a bit longer due to the thickness that you're casting your parts in. Once the material is fully cured, we can go ahead and disassemble the mold. Here's again our soft plug, comes out no problem. And you can see some of that excess flashing on top here that can go between the mold and the support shell. That's why we put that releasing agent on there. And a little bit of talc powder again on the rubber will help facilitate that demold where the silicone glides over itself. It will reduce the surface tension. So a little bit of baby powder in your toolkit is really helpful. And here you can see clearly why I chose to use the Dragon Skin 10 for this project. It is very stretchable and durable. I can pull on it and peel it away just like a glove over my casting without worrying about ripping and damaging it. And here you have the finished casting. Now I'm going to have one of my coworkers here. He's our in-house painter. I'm going to have him do the painting job on this because he does have a bit of a better eye for detail, and he's going to add realistic color so that we can add this to our final sculpt that we did off the golem. Now, keep in mind that different artists have different painting techniques and finishes for their castings. And here, my coworker Kevin did a couple different washes and layers to get the right skin tones, and then ended up sealing the entire piece by using Krylon Crystal Clear sealer. Now, if you guys want to check out some more finishing and painting techniques for resin castings, make sure you check out our live presentation that my coworker Kevin did that you can find in the description below or on our YouTube channel. And here you can see the final result of what the hand looks like when it's added to the installation. This is an installation that was done for our Reynolds Advanced Materials distributor. I'm really happy how this project came out because we were able to minimize any kind of cleanup efforts on the casting itself, and the mold picked up all the detail and transferred it into our casting. And of course, because we used the right casting material, we're able to do a thin-walled casting without having to do a heavy casting that will be difficult to adhere to the current prop as it sits. Now, if you would like to give your own project a go and need some casting and mold making materials, please visit any one of our distributors around the world. And there you have it, a step-by-step procedure that I use to create fast turnaround molds and castings. Now, let's just take a look at our project goals. We were able to create a detailed mold and capture all the detail on our original sculpt by using a little bit of compressed air on the first layer we did. We also were able to create a seamless glove mold in order to minimize any kind of post-finishing cleaning that we have to do on the casting coming out of the mold. And of course, we showed you how to use fast-setting materials in order to create a mold and castings in the same day. Now, if you have an idea about what we should do next, please let us know down in the comments below. If you like this video, hit the thumbs up button. To keep up with our latest mold making, casting, and other videos, remember to subscribe.